Hey guys, welcome again. So after we have provided a tutorial on the linear regression, so we can now look at the second section, which is the hypothesis testing. And in this case, we have three questions. So the first question requires you to state the null and alternative hypothesis. I think the second one is the same. And the third one, we have to do some more analysis on the hypothesis testing. We're going to start with the first question. So let's put this on the side and try to look at these questions. So the first question states, a researcher believes that a new medication reduces cholesterol levels by 25%. So that is actually the belief. That's the existing knowledge that we have. And you can remember when we state our hypothesis, the null hypothesis goes with the information which is available, or the current belief, or the perception. And then it says, however, results from a medical trial suggest that the actual percent reduction may differ from this claim. So this is an alternative interpretation of what has been believed. And in this case, we are supposed to just state the null and alternative hypothesis. This question looks more or less the same to examples that we did in class together. And so the first one says, suppose we want to show that only children have an average higher cholesterol level than the national average. And it is known that the mean cholesterol level for all Americans is 190. So you can see that this is the existing knowledge. And that is our null hypothesis. And the alternative is what we want to do. And in this case, you can see that we are dealing with the average. And it says we want to show that only children have an average higher than the cholesterol level. So the alternative hypothesis is focusing on something higher. So is this the same as your final exam? So let's go back here. You can say that there is a belief, the amount or the cholesterol level that can be reduced by the new medication. So that's the existing knowledge. But new results suggest that the actual percent reduction may differ from this claim. The outcome may differ from this claim. So that means we may have a little bit more or a little bit less, but not exactly 25%. So going back to the first example, we could create a hypothesis as follows. So in this case, our null hypothesis can be written as follows. First, we should start with mu, or the average of the large data, or of the population, or we can say the hypothesized average. And it says it is equal. So the existing knowledge is actually 190. So I'm going to write there 190. And I'll give probability to the null hypothesis, which is 95%. And actually that is our confidence level. Now the alternative interpretation to this means that we are going to have mu, which is average of the large data. And now we are looking at the average higher than That's all we are trying to show. And so to show something higher than, we have to use that the higher than, and that should be more than 190. And we need to prove that with the p-value which is less or equal to the remaining, which is 5%, and that is the significance level. Now, if you can remember, we cannot write the hypothesis, the null hypothesis, like this when the alternative hypothesis shows it is greater than 190. So that means we have to go back and change this sign here, or the inequalities. So that should be less or equal. You should know that for the null hypothesis, we can write equal when alternative hypothesis has not equal. But also, we can write less or equal when alternative hypothesis, we can write greater. And also this one can be greater or equal when the alternative hypothesis is less. So I'm not expecting any of you guys to write not equal with the null hypothesis, or even to use this symbol with the null hypothesis, or this one. We know that the null hypothesis should have equal, less or equal, or greater or equal. For the alternative hypothesis, we should have not equal, greater, or less, and they should go together. When we have greater, then the null hypothesis should have less or equal, and the opposite is true. And this is two-tailed, meaning that it can be less. The alternative hypothesis can be less or can be more. But here we are focusing on one direction, which is greater, and also we are focusing on one direction, which is less. So for this particular question, you can see that we could write our hypothesis like this. So going back to the question that we have, so as we said, a researcher believes that a new medication reduces cholesterol level by 25%. So that's actually the null hypothesis. Now, the new study suggests that this can differ from the claim. The outcome can actually give us different outcome, and that outcome can be less than 25, or can be more than 25. And so, can you please decide what kind of hypothesis we are going to create? That's all with the first question. Let's look at the second question. And this one states that we want to test if SNHU students take less than 5 years to graduate from the college on the average. So we will consider average, same as what we did here. Here we have also to consider the average, although we are talking of the percentages, but let's consider average. So we want to test if new students take less than 5 years to graduate. So the existing knowledge should be that students should take 5 years. So the null hypothesis should be 5 years. However, we want to find out if the students take less than 5 years. So what sign are you going to use for the alternative hypothesis? Definitely will be this one, less than 5 years. So the null hypothesis should definitely take this sign, greater or equal to 25, and the alternative hypothesis should be less than 25. So let's go to question number 3, which requires some calculations. It says the owner of this company claimed that the height of the bread is on average 15 centimeter. So that is the existing knowledge. That's the claim of the owner of the company. Now, the customer believes that this owner is wrong and that the average height of the bread should be less than 15 centimeter. This is what the customer comes up with the new idea. So the existing knowledge is 15 centimeter. The customer decided to do a hypothesis test, and so he collected from the store 10 samples of bread and find the mean height of the sample as 14, and so he got information from the owner that the standard deviation, so that's the population standard deviation, to be 1 centimeter, and the distribution of the heights is normal. Based on this sample, who is right, the customer or the baker? So the first thing to do here is to state the null and alternative hypothesis. And then we need to find the z-score, and then from the z-score we find the p-value and compare the p-value with the significance level, and to see if we can reject the null hypothesis or fail to reject the null hypothesis, and we have to explain why. And then based on this sample, we need to find who is right. Is it the customer or the owner of the business? And we have to explain why. So just as we did with the first and the second question, we need to develop the hypothesis. And I will bring back the question which we had in class. So after we have created the null and alternative hypothesis as we did here, now the next thing is to do some calculations, and so we need to test with this sample, the 100 sample of children who were tested. So I'm going to organize this information here. The sample size, which is n, the sample size is 100. That information is important. And the second information we need is the average. So that's the average of the sample. So I'll say average. The average of the sample should be, it is stated here 198. And you can see that we are assuming that the average should be greater than 190. And so when we did our study, we found the average of the sample to be greater than the average, the hypothesized average. And we want to know if this amount is significantly greater than 190, or maybe it can be within the limits or within the margins of error. Anyways, let's proceed. After having the average, then we need to know the standard deviation. And in this case, if you can remember, we have to find if the standard deviation is of population or it is of the sample. if the standard deviation is of the population, then we will use z-test. But if we have to use the standard deviation of a sample, we have to use the t-test. So here, the standard deviation is of a population, which is 15. Now, let's look at the question. So, you can see that we have the hypothesized average. And after the customer decided to do the hypothesis test, he came up with 10 loaves of bread, which is the sample size. For me, I have 100. And then the average height of the sample is 14 centimeter. For me, my average is 198. And you can see this is less than 15. And therefore, is this significantly less than 15? But also, you need standard deviation. Let's see if the standard deviation of population is provided. Yeah, this information was provided by the owner of the business. And so that is the standard deviation of a population. So that's the information which you need, and you can organize yourself like this. So why do we need all this kind of information? It is because we can find the z-score or the z-value. So to get the z-value, we use the formula, which is the average of the sample minus the hypothesized average, and you can close the bracket. And this one, you need to divide by the standard error. And so the standard error will be the standard deviation divided by the square root of n, square root of the sample size, which is n. So let me close the bracket here. So you should use this kind of a formula to find the z-value. So let me work on my example and see if you can do the same. So to find the z-value, I'm going to take the average of the sample. So that's the average of the sample that we had, which is 100. For you, you have 10. So I'm going to take this one. So I'm going to put equal sign so that I can use Excel function. Take 198, the average of the sample minus the hypothesized average, which is 190. So I'm going to put 190 here. I was supposed to organize this clearly. But anyways, so I'll close the bracket. And then I will divide this and put one more bracket. And so that will be the standard deviation of the population divided by the square root SQRT. So I'll select the square root SQRT, or the square root of the sample size, which is 100. For you should be 10. And then I will close the bracket, and again another bracket. So you can see the way I put my brackets. And if you can enter you will see that the z-value is 5.33. So I'll put this into 2 decimal points. So that's 5.33. And in this case, I have already fulfilled the second part of the question, and that is to find the z-score. Now I'm going to work on the third, which is to find the p-value. So the p-value, or the probability value, can be found from the z-value. So how do we do this? Just put equal sign and type norms inverse. Now you can either do like this, norm dot s dot norms dot s dot inverse, or you can just say norms inverse and norms test. You have to select this one, norms test. And so in this case you have to put the z-value, and I'm going to click on this z-value and close the bracket. But before you enter, you can see that the z-value is positive. It should be negative for you to apply this function, but if it is positive, then you should take 1 minus, and then you will get the probability value. So for me, let me see what kind of probability do I have. It is 0.000. It's a lot of zeros, and so it is actually 0.0. That's the probability. Oh, that's my p-value. Now, based on this p-value, which is it's way less than 5% significance level, so it means that I can reject the null hypothesis. And so I'm going to reject the original idea that says all Americans have 190 cholesterol level. But in fact, my new study have come up with the suggestion that children have more than 190 cholesterol level in average. So the null hypothesis that says is less or equal to 190. So my outcome will say that, or will support the idea that the average cholesterol level of the children in US, they do have a significant amount which is greater than 190, and that's proved by the probability value of less or equal to 5% significance level, and that's our p-value. Let's see what else do we have. And so we are supposed to compare the p-value with the significance level. So do you reject the null hypothesis or fail to reject the null hypothesis? That's what actually I've said here. We can compare this p-value with the significance level, which is, so let me write here, our significance level above is 0.05. And the p-value is actually less or equal to the significance level. And therefore, we can reject the null hypothesis. That means children have higher cholesterol level than the national average. And so here it says, based on this sample, who is right, the customer or the baker? And explain why. So in my case, the new study is correct, but the belief that was there before was not correct. So in this case, do you think the 14 centimeter is significantly less than 15. It should be less than 15, and it should be significant. And you can prove this by using the p-value. So you can follow my example and work on this question. As you can see, it should not take too long for you to complete it.